Good morning, everybody, and welcome to this first lecture with our postgraduate course under the title of Wireless Sensor Network for Communication and Information Engineering program. This is Samah Ablatif, and this is our first lecture with this postgraduate module. So let me first start with sharing screen with our zero lecture dealing with the module outlines. As I just illustrated, this is our first lecture with the wireless sensor network module. And as you can see, this is a postgraduate module with 6-level codes, 619 CIE for the communication and information engineering. And maybe it's important now to describe some sort of difference between having a postgraduate courses and having an undergraduate course. Whenever we are considering a postgraduate course, especially when your audience is toward having their Master of Science, I think that including more and more research aspects is one of the very important parameters while formatting the course. That's why maybe the general title of our course is Wireless Sensor Network. However, I will choose a subtitle for this course, at least for this academic year 22-23, under the name of Wireless Self-Powered Sensors. So during this course, we will give a very special focus on self-powered sensors as one of the most booming technologies nowadays, especially when we are considering low power application, such as an IT, Internet of Things, or IoT Square, or Internet of Tiny Things applications. Generally, when we consider a wireless self-power sensor, this node or this sensor first constructed of a sensor or a sensing part. Generally, as you know, sensors are defined by these devices that can convert a physical phenomenon into some sort of an electrical signal in forms of voltage, current, variation, resistance, or whatever. And part of this course, as you will see in this module outlines lecture, is how we can fabricate our sensors with a special focus on nanosensors. Then we have a controller. You can call it a controller, you can call it an embedded system, you can call it an intelligent point, where you can manage this data coming from the sensor to be then transmitted over either an RF transmission, maybe an optical transmission or whatever. And this block illustrates the wireless part in our sensor. And in order to operate all these stuff, you need energy. This energy can be captured from a standard battery, where you have the problem of lifetime. As you know, battery's lifetime is considered as one of the most important weak points or significant weak points in any wireless node. So another replacement is to have an energy harvester and a renewable energy low power source that generate energy in a continuous manner so that you can power your device using this energy source. And this is why we call our sensor a self-powered sensor. And obviously, in order to have all these blocks, you have to have a connecting circuits, or what we can call an interfacing circuits, that interface each stage of these units to the others. For example, sensors all usually generate a voltage or current in a very, or sense a voltage or current in a very low scale, maybe in a microvolt, microampere, and so on. So you have to step up, or what we can call boost this voltage into the next stage, where you can control the data to be transmitted and so on. So generally speaking, each of these units is connected to the other using what we can call an interfacing circuit. So generally speaking, what we are going to study in this course is these units. Of course, we will not be able to make a very in-depth analysis to each and every block, but at least we are going to make some sort of an overview for each block, and we are going to demonstrate what is the up-to-date research in this block based on literature. If you remember my words at the beginning of this lecture, I told you that usually we are using these wireless self-powered sensors for operating some low-power devices. Usually here we are considering the most famous term now in our environment, which is the IoT applications. And again, if you remember my words concerning the difference between postgraduate and undergraduate courses, when I told you that postgraduate courses are more toward research aspects. Here you can see to what extent the term IoT and the term wireless sensor networks are very widely spread in literature among youth. Number of publications per year is a very good indication to detect to what extent this topic is promising in the literature. And of course, this overlapped area where we have wireless sensor networks and for IoT application is again an increasing area in literature in terms of number of papers, of course. Okay, so what is our module focus? What we are going to focus about? Again, I think what we are going to do is that we are going to refer back to this diagram. So referring to this diagram, the first block is the sensors. How we can construct a sensor. A sensor is a very fundamental electronic device. So we will go to the fundamental of electronics to study how sensors are fabricated. And as I told you, we will give a very special focus on nanoscale sensors. We will give some examples for biomedical sensors, like the one you see in this slide. Also, we will consider gas sensors, temperature sensors, how we can fabricate these sensors, what is the most recent technology in this matter. The second block, if you remember from the diagram, is energy harvesting. Usually, there are three main sources of energy harvesting, which are light, vibrations, or pressure, and thermal energy. Light is harvested by light harvesters, or what is globally named by solar cells, but it's not only solar, because you can harvest also the indoor lighting. Vibrations and pressure are harvested using a piezoelectrical materials, and thermal energy is harvested by using a thermoelectrical materials. So we are going to focus somehow on these three aspects of energy harvesting. Then the linking circuits, the interfacing circuits, for example, the DC-DC converters, one of the most used interfacing circuits to push up or push down, or what we call to boost or back the voltage, of course, in this low power scale, and other interfacing circuits used in our node or in our wireless sensor node. Another aspect is wireless charging, which is now a very promising technique, because sometimes it's not so convenient to have a wired charging for your node. So sometimes you are using, or you are pushed to use, or you are forced to use wireless charging to charge your node. Here we will give focus on optical wireless charging and RF, which is of course the most famous wireless charging. Finally, as I mentioned, it's now something related to research. And one of the very important aspects toward research is informatics, or utilizing machine learning. So we will study how we can utilize some sort of a machine learning models, or artificial neural network, or generative AI, artificial intelligence models, in order to optimize our devices, even in order to create what we can call a decision-making unit for our nodes. This is briefly the content of our module, where you can find a complete list of content here from chapter 1 to chapter 7, where we have our complete syllabus or content for this module. Finally, as you can see us now, you can follow us in YouTube to have the full module recorded. So after the delivery of each lecture, you will find the lecture uploaded on the YouTube. We will have a dedicated playlist under the name of Wireless Sensor Network CIE619. So you can follow the lecture by lecture. And I think it will be the full lecture uploaded on our YouTube channel. Concerning the assessments, and of course, this is something very critical whenever we are considering mocks. If you check the module specs of the module, you will find that we have a 70% for an NC exam and 30% for coursework. This 30% will be offered mainly on what's called a white paper. Maybe in another session, we will describe in more details what we mean by a white paper, or what is the definition of white paper, and how you can construct a white paper for a certain topic. So you will pick up some topic, for example, optical wireless charging, and then we will start together across the 15 weeks of the course to write what's called the white paper. It's not only related to read from literature and to learn more from reading the papers, but it's also very fundamental in terms of report writing, demonstrating data, judging data, and also constructing a document, because this is a significant step for any researcher as far as you are intended to have your master's in science in this communication and information engineering program. Our next lecture will be chapter 1 under the name of sensing mechanisms with inside depths on nanoscale sensing. Thank you very much for your attendance, for your listening, for your concentration, and see you in next lecture, inshallah. Thank you very much.